A monomial is simply one term. And we're talking about quotients of monomials, and basically what it means is that we are going to be reducing fractions, so single fractions. Now, last chapter we talked about some of the laws of exponents. So far we have this. When you're multiplying with the same base and two different exponents, you add the exponents. Only with multiplying, not with adding them. And we have, if you have two numbers multiplied together raised to a power, then you can distribute the power. And these are in your notes. And we had this, where we multiply power to a power. Now, what's different here, these all apply, still they all apply with fractions. A can be a fraction, B can be a fraction, they can be rational numbers. So we're going to talk about what happens now specifically with dividing. Now with fractions, we have three very similar rules because dividing is just the opposite of multiplication. So if you have the same base with two different exponents, if m right here is greater than n, so you're looking at the exponents, m and n. If m is greater than n, then we're going to subtract the exponents. We'll subtract m and n. Put the bigger one first because we don't want a negative. So you could have a to the m minus n. Now, if this exponent is bigger, and this really should be written right up here, so not right there, right here as an exponent. If this exponent is larger than this one, we're still going to subtract, but we want to subtract the smaller one from the bigger one. So we would have 1 over a raised to the n minus m. Basically, we're going to subtract wherever it will make our exponent positive. Now, for this last rule, this should look pretty familiar. We had a product where we distributed m. So now we have a quotient where we're going to distribute m. Now the assumption for all of these is that the denominator is not equal to 0. For our first example, I'd like to start by separating the constants, which are the numbers, and the x's and the y's into three different parts. So that we can look at their different components. So we're going to start with 9 over 3 times x cubed over x squared times y squared over y to the 5th. Now, we know what 9 over 3 is. 9 divided by 3 is simply 3. Now, our rule tells us that we're going to subtract these two exponents. So let's look at the x's. The x is bigger, so our x's will be in the numerator. And we subtract 3 minus 2, that's a 1, and we don't really need to write 1. We can make the assumption that that is 1. And then, for our y term, the 5 here, this is the larger one, so we're going to take it to the denominator, like this. So 1 over, and we're going to subtract, which gives us a 3. And then for our last step, we would really like to write this as a fraction. So 3x over y cubed. Now for this example, we're going to do the same thing. We're going to reduce our constants, reduce our variables. So let's rewrite this. This is a temporary step that I'm using, and if you don't feel like you need to use this step, then you certainly don't have to. Now we're simplifying here. Now 4 over 18. 4 does not divide evenly into 18, but 4 and 18 have a greatest common factor of 2. So 2 will go into both of those numbers. So let's make a note of that the GCF is equal to 2. So that means that we can reduce 4 over 18 by dividing 2 into 4 and 2 into 18. And that will leave us with 2 over 9. 4 over 18 is equal to 2 over 9. Now, that a cubed over a, it is understood that that's a 1. You don't have to write the 1, but you can understand that it's there, which means that we are going to subtract 3 and 1, which leaves us with a squared. And then for the last one, this 4 here, this b, this 4 right here, this is where it's larger, so we're going to move the b to the denominator and subtract. And again, there's an understood 1 in your numerator, and that gives us a simplified expression of 2a squared over b cubed. Now, a note about this, just a little side note. Let's take a look at this part. Let's look at this a section about why we can subtract those exponents. We have a cubed is really a times a times a divided by 1a. Now, this a divided by a, that is equal to 1. And what's left is a times a, which is just a squared. That's how we can do this with the exponent. For this example, take a look at the denominator. What do you notice? We have some parentheses right here, and we have an exponent. So we still have to follow the rules of PEMDAS. Still have to follow the order of operations. So first, before we simplify, we're going to distribute that square. Okay, so 2 squared, that's 4, and x squared, and y to the 4th. Alright, this is not a simplified monomial, but we want to simplify it. So 2 over 4, I'm going to show you something that I like to do when I'm reducing these. Since 2 and 4 both go into, the 2 goes into both of these, I'm going to reduce that, make that a 1, make that a 2. So I'm dividing. Also, x squared and x squared, this makes a 1, so I can cancel both of those. And I can go ahead and start subtracting my exponents from here as well. So I'm going to be subtracting 2 from this 4 right down here. So I'm going to mark this out and make that a 2, and I'm going to mark out that y entirely because it's going to be gone. And then for our answer, we write down what's left. Now in our numerator, all that's left is a 1. In the denominator, what's left is 2y squared. You can try this canceling method. We're going to do one more example, and at a point in the video I'm going to tell you that I want you to pause the video and then try it yourself. Okay, let's take a look at this example. There's a lot to it. We're going to distribute a square right here. Right here, and I'm not sure what happened there. But we can turn this around. Alright. Move that up here. Okay, well, we're going to distribute that square anyway, and hopefully your stuff is not sideways. So we're going to start by distributing the square, and that gives us p to the 4th. Now we're also squaring the 10, so 10 squared is 100, and we have 100k squared. Now we need to multiply all of this together, so we're going to have, all of this is multiplied together. We can imagine that it's all on one fraction at the same place, so we can simplify from here actually. Now 5 and 100 both have a common factor of 5, so we can divide that. That leaves me a 1. It leaves me a 20. And then the p over p to the 4th and p to the 3rd, well, 4 minus 3 leaves me with a 1. That leaves me with nothing. And then we can reduce the k's. Now k squared divided by k squared leaves me a 1. So we've canceled almost everything, so we're going to write down what's left. We're left with 1p to the 1st. You don't need to write those ones, they're understood to be there. So we'll have p over 20. And we'll try another example where you can try one yourself. Okay, 4x over 3y to the 7th times y to the 4th over 2x squared cubed. Now at this point, I would like you to distribute your cube into your parentheses, and don't multiply yet, and stop the video. And I would like you to write it down and try it yourself, and then when you've gone through that step, then start the video back. So did you get this answer? Remember, you're going to multiply those exponents and multiply these exponents. But 2 to the 3rd is 2 times 2 times 2, which is 8. So you don't multiply those. Now we do multiply. But looking at this, I can go ahead and simplify without having to multiply yet. Because 4 and 8, 4 goes into 8 evenly. It goes in 2 times. So I'm going to go ahead and start canceling. Now let's look at our y's. 12 is the big one, so we're going to the numerator. So we're going to subtract 12 and 7, which leaves us a y to the 5th right here. And what about those x's? X to the 1st makes this one x to the 5th. Now I want you to pause it again, write your answer down, and then restart it and see if you get the same thing I got. And here's the final answer.